Hi everyone, this is Mrs. GA, and today we're going to talk about triangle inequalities. So first let's talk about the triangle inequality theorem, which says the sum of any two side lengths of the triangle is always greater than the third side. So remember, sum means to add. So this says we can add up two sides, and that sum should always be bigger than that third not included side. So here you can see that there's always going to be three separate inequalities that you can set up. So you include any combination of the sums in the third side. So here AB plus BC is greater than AC, BC plus AC is greater than AB, or AC plus AB is greater than BC. So you should be able to set up three inequalities for any triangle. So for example 1, it says, is it possible to make a triangle with the following lengths? So whenever we're doing this, we have to set up three inequalities to show that a triangle can be made, or maybe it can't if we end up with an inequality that is not true. So again, we have to do every combination of sums of two sides. So first, let's do 3 plus 5, and that must be greater than 9. So I did the sum of the first two. Now let's do the sum of the second and third. So 5 plus 9 must be greater than 3. So I did 5 plus 9 is greater than 3. And now let's do 9 plus 3 is greater than 5. And let's make sure all those are true. So that first one says 8 is greater than 9. So right off the bat, I see that the sum of these two sides is not greater than the third side. So I don't even need to check the other ones. I know this is not true. So is it possible to make a triangle with those sides? No, it is not possible. Okay, let's try this next one. Again, let's set up all three inequalities. 24 plus 8 is greater than 30. 8 plus 30 is greater than 24. And 30 plus 24 is greater than 8. So let's double check this together. This one says 32, I'll do it in blue, 32 is greater than 30. That is a true statement, so let's move on to the next one, which says 38 is greater than 24. So that is also true. And last, we get 54 is greater than 8. So we see that we have three inequalities that are true. So that means that, yes, these could be the three lengths of a triangle. All right, so now we're going to find the range of possible values for a missing side. And we're going to use the triangle inequality theorem to do that. So even though one of my side lengths is x, we don't know the value, we're still going to set up three inequalities just like we did above. So we're going to add up the two sides. So we'll say 18 plus 9 must be greater than x. And then let's do 18 plus x must be greater than 9. And 9 plus x must be greater than 18. So we're setting it up the same way, even though we have a variable. And then let's simplify what we have, and if necessary, let's even solve for x. So here we can say 27 is greater than x. Here we can solve by subtracting 18 on each side. And this tells us that x must be greater than negative 9. And here we can subtract 9 on both sides, and this tells us that x must be greater than 9. So let's look at the information we know. We know, and I'm going to rewrite this in the opposite order. So notice I just simply flipped both sides and my inequality sign. For me, it's easier to read from left to right. So we know that x must be less than 27. X must be greater than negative 9. I'm going to cross that out because, well, we can't have a negative side length anyway, so this is kind of a vague piece of information. And we also know that x must be greater than 9. So here I see x is greater than 9, but less than 27. So that means my lower boundary is 9, and my upper boundary is 27. So you can see that I kind of put these two together to say x is greater than 9, but less than 27. So those are any value between 9 and 27 would be acceptable for this side length. All right, so now we're going to start talking about the relationships between the sides and the angles in a triangle. So this says if two sides of a triangle are not congruent, then the longer side is always opposite the longer angle. We can also use logic and conclude that the shorter side is always opposite the shorter angle. So in example 3, they're asking us to order the angles from least to greatest. So we know that the smallest angle will always be opposite the smallest side. The largest angle will always be opposite the largest side. So if I want to start with my smallest angle, I'm going to look for my smallest side, and then I look opposite of it, and I find that angle A is the smallest angle. Now, for the middle angle, I'm going to look for the middle side. 32 is the middle side, so if I look opposite, I see that I find angle B is the middle angle. And then I need the largest angle, so for that, I will look at the largest side, and if you look opposite, it is angle C. So remember, the smallest angle is always opposite the smallest side. The largest angle is always opposite the longest side. Let's try that for this part B. Again, to start with the smallest angle, I find the smallest side, which is 7. I look across and I see angle B. The next side length would be 24. That's the next smallest. So I look across and that's angle C. And then my longest side is 25. So that means my largest angle is across from it, which is angle A. And that's the order from least to greatest. Okay, so now we're going to look at the relationship between the angles and the sides. So this is kind of the opposite of what we just did. This one says if two angles in a triangle are not congruent, then the larger angle is always opposite the longer side. So here, again, we're just doing the exact opposite, except we're going to start with the angles to order the sides from least to greatest. So if I want the smallest side length, I'm going to start with the smallest angle, which in this case is angle B. So if you look opposite of that, I have the shortest side, which is CA. The next smallest angle would be 60. So if you look opposite of that, we see that side CB is the next shortest side. And then for the longest side length, I find my largest angle, which is this 90-degree angle. I look opposite, and I see that my longest side will be AB. Okay, let's try one more together. Again, my shortest side, the least length, will always be opposite the smallest angle. So angle A is opposite of side CB. So that's my shortest side. And then I'm going to find the next smallest angle, which is B. I'm going to look opposite, and I find AC. And then my largest angle is angle C. Opposite that is side AB. So that will be my longest side. Okay, so let's see if we can use what we know about triangle inequalities to help us with this word problem. So this says, a hole on a golf course is a dogleg, meaning that it bends in the middle. A golfer will usually start by driving for the bend from A to B, and then using the second shot to get onto the green. So you're starting at A, usually they'd go here, and then they'd try to hit it to where the hole is. However, Sandy believes that she may be able to drive the ball far enough to go straight to the green. So she thinks that maybe she can make it all the way from A to C. And that means that she can avoid this bend and she can save a shot. So Sandy knows that she can accurately drive a distance of 250 yards. Should she attempt to drive for the green on her first shot? So pretty much we have to figure out, is this side length, could it be less than 250 yards, or do we know that it must be more? So we're going to use our triangle inequalities to do this. So let's call this side length X, and let's set up our three inequalities. We know that 103 plus 110 must be greater than X. We know that 103 plus X must be greater than 110, and we know 110 plus X must be greater than 103. So for this first piece of information, we see that 213 is greater than x. So we see that x is less than 213. I just rewrote it so I can read it a little easier. Here, if we solve for x by subtracting 103, we see that x must be greater than 7. And here we get x is greater than -7, which is too vague for us to use. So let's look at what we have. We know, using triangle inequalities, that the length from A to C must be greater than 7, but less than 213. And since we know for a fact that this length cannot be greater than 213, well, that means that Sandy should take the shot, because Sandy thinks that she can hit 250 yards. So we would say yes, because AC must be less than 213 yards. And there you have it. So here we were able to use our triangle inequality to help us solve a real life problem. All right, that is all for today's video. Thank you so much for watching.